Welcome to my YouTube channel and the website Global Math Institute. Here is another video with IB student Arya. We are going to discuss trigonometric identities related to compound angle formula. We have a set of questions based on related acute angle, correlated angle, trigonometric equations, and trigonometric identities. Hope you find good solutions for examination style questions in this video. You can master the strategies and succeed, and also develop critical thinking skills by joining my classes. Let us enjoy the journey of success and understand the concepts of trigonometry with the student Arya. Hi Arya, how are you doing?
Hi, hello sir. How are you? I'm good.
Very good, very good. So today, what do you want to learn?
I have this homework sheet. I just thought that we can maybe clear some concepts for like trig identities because
Okay.
we learned all of them last week. So I thought that if we can do that, that would be good. So I'm
Sure.
just here.
Sure.
So this is the questions. It starts from here.
Okay. So,
I did question one.
mm-hmm.
The only question I had was for J.
Okay.
I
Cos
didn't
square
understand
2 plus sine square 2, right? It is just 1. Cos square
why is
theta
it
plus sine square theta is 1. So just write it 1, right? Simple as
why
that.
is why is it one?
Formula sine square theta plus cos square theta is 1. Theta is 2 here.
Oh. Oh, I see. It's a Pythagorean identity.
Identity. Correct.
Oh, okay. I see.
Next question, please.
Um, okay. I did all of this. I understood
Correct.
this. And I understood this one as well. So, and I understood this. These ones.
Okay. Question number 5, you mean, right?
Yes.
Very good. Actually, it's a difficult question. I will show you a strategy to answer such questions, right? So
Okay.
my strategy is, let me write down my strategy so that you understand and then we'll follow through. So we are doing question number 5 now.
Right.
Can you please read the question?
Evaluate using formulas developed in this section. So all the formulas that we
Correct.
use.
So my thing is, before we get into details, you remember related acute angle?
Yes.
Very important. Related acute angle. My first step is to write all the expressions as equivalent expressions.
Okay.
Using related acute angle, correct? For
Correct.
that, what you really need is just two things. One is the cast rule, and then you have to see the related acute angle. So you have the sign from the cast rule, right? So
Right.
I'll show you how to do this. Question 5a. Can you read the question? Sine 11 pi by 12,
Sine
right?
11 pi over 12. Yes.
Sine 11 pi over 12.
So our related acute would just be pi over 12, right?
Yes, let me just show that. Beautiful. See how simple it becomes once we get this concept, right? So 11 pi by 12 is all this, where this angle is one short of 12 by 12, right? Do you see that?
Right.
So it
Yes.
is pi by 12. So the related acute is pi by 12. Also, you know that sine is positive, right? You know the cos rule.
Right.
Since sine is positive, I will write this as sine of pi by 12. Does it make sense to you?
Right.
Now this is equals to sine of, now we want pi. 4 minus 3 is pi, right? So 4 pi minus 3 pi by 12. Does it make sense?
Oh, okay. So I did this, but then what I didn't know is that I was supposed to use the related acute. So I got stuck when I had 5 pi over 12 because I used
Yeah,
6 pi over 12. So that's because I used the formula because I know here they're just asking for is your sine a plus b is what you
right.
do, right?
That gives you 4 pi by 12 is pi by 3, right?
Right.
Minus pi by 4. So now you can apply the formula sine A minus, correct?
Right.
So you have sine A, which is sine of pi by 3 cos pi by 4 minus cos of pi by 3 and sine of pi by 4, correct?
Correct.
Now you have to use your special triangles. So always sketch your special triangles right in the beginning, right? Do not
Right.
think over it. So this is your special triangle, pi by 3 here, 1, 2, and square root 3. And this is your special triangle, pi by 4.
Which is pi over 4, pi over 4, 2, 2 root 2.
Yeah, so you could use, you could use square root 2, 2, yes. And now substitute the values. So sine pi by 3 is square root 3 over 2.
Right.
Cos pi by 4 is square root 2 over 2. Minus cos pi by 3 is half. Sine pi by 4 square root 2 over 2. So you have a common denominator of 4, correct?
Right.
Square root 2 square root 3 gives you square root 6 minus square root 2. So that is the final answer for this particular question. Is that clear to you?
Yes.
Easy. So we just showed that sine of 11 pi by 12 is positive and is equal to square root 6 minus square root 2 over 4. Perfect.
Right.
This is the simplest way of solving this question. And if you do this, you probably save a couple of minutes for the next question. Okay?
Right.
So once you are done, we'll erase and then pick up the next question, please. Tell me.
Okay, I'm almost done.
No problems. Understand.
Okay, done.
Good job. So we will not solve them in details, but we'll write them in a compound angle formula. Cos 13 pi by 12. Can you tell me? Cos 13 pi by 12 is equal to what?
Just in general, it's just your you have your related acute of pi by 12.
Minus, because it is in
Pi by
quadrant 3, right? So
Right.
minus cos pi by 12. Is it okay?
Right.
So when you are looking at it, you are in quadrant 3, in which only tan is positive.
Right.
Right? So apply the cos rule. I'm going to repeat this so many times so that you do not make a mistake here. Now pi by 12 you know how to write, correct?
Yeah.
Pi by 12 is 4 pi
Pi
minus
by-
3 pi, which is, last time we did exactly same.
It's just
Tan
your
of 7 pi by 12. Now tell me this. Tan of minus 7 pi by 12. How will you do this?
you have to go clockwise. So your related acute will be in the C quadrant, the fourth quadrant, so it'll be tan would be negative. And
So,
so your related acute would just be 5 pi by 12, negative 5 pi by 12.
okay. So it is this angle, which is 5 pi by 12, correct?
Right.
The related acute alpha I'm talking about. Is that clear to you? 7
Right.
plus 5 is 12. Beautiful. And so we are in quadrant 3. Very good, because it is positive there, right?
Oh, I see.
Cast rule. So therefore, I could write this as tan of 5 pi by 12.
Right.
How do I get 5 pi? 3 plus 2.
Plus 2. And so that's just
Tan
your
of 3
pi
pi
over 4.
plus 2 pi by 12 each, right?
Right.
Which is positive tan pi by 4 plus pi by 6. Done. You can now expand. You remember tan formula?
Yeah.
Tan A, tan A plus
It's
tan
tan
B,
A plus B, 1 minus tan AB.
tan A, tan B. Perfect. Apply the formula, get your result. That's so simple, right?
Right.
You can do it, find the exact value, no problems.
Yes.
Good job. Can I erase?
Yes.
Very good. That's the confidence. Next question, please. Which one you want me to do?
I think we'll just go in order to make sure that I understand
Great.
everything.
So,
Um,
Sine of 75 is 45 plus 30, right?
Yeah.
Cos of minus 13 is same as, see, now cos of minus 15, see, cos of minus 15 is same as cos of 15, correct?
Right.
Because an even function, right? It's important. So write in terms of related acute angle. Cos minus 15 is cos 15. And how do you get cos 15? 45 minus 30. And now you can expand using the cosine formula, which is cos A cos B
Sine
plus
A sine B.
sine A sine B. And you know the special triangles, substitute the values, calculate the answer. Is
Why
that,
is cos minus 15 even with cos 15? Is that a symmetrical law?
yeah, because you know, let's look into the graph. Good question. So cosine graph is kind of like this. You remember?
Yeah, it's
You
like,
see, it is
yeah,
axis of symmetry is y-axis. It's an even function.
right,
You know, cos of minus theta is equals to cos of theta. Now, if I draw the sine graph, then the sine graph is kind of like this. Do you see that? It's an
right.
odd function. Sine of minus theta is minus sine theta.
Oh, I see.
And even otherwise, from the cast rule itself, you can figure out. You know the cast rule?
Yeah,
CAST. If I take angles on this side, then you know cos is positive, right? Minus is clockwise. And so 15 plus or 15 minus will give you the same value.
right,
But for sine, it is negative here, right?
right,
Sine is negative in quadrant 2. Cos is positive in, positive in quadrant 2. Cos is positive in quadrant 4. Correct?
correct,
So that is the key, right? Okay,
right,
so we're done question number 5. Perfect. Let's move on to the next question, which is question number 6.
right.
Find the value of each of the following. You just need to expand. They've
If
already given you the thing, right?
you have your A and B and you just put it into your formulas and then go from
Perfect. Now, I would suggest here something for cos of minus pi by 6 and minus pi by 4. Let me rewrite cos of minus pi by 6 minus pi by 4. Too many minus, right? I
there.
could
Right,
take this minus common, right? Then what do I have? I get plus, right?
right,
And you know, cos is an even function. So I could write this as cos of pi by 6 plus pi by 4. Does it make sense to you? So
yeah,
it's much better to work with the positives rather than two negatives. You get the idea. And then
right,
you continue. So that is how you should do it. That will help you to get the right answers, right? Now, tan term, we have negative first, then positive. Better to write, switch the order, right? So you get tan of 2 pi by 3 minus 3 pi by 4, correct?
right.
And then apply tan A minus B form, right? Now, still
Because
there, yeah,
the when you change the values, it doesn't matter, right? Because it's
no,
still in the same order.
yeah, it is A plus B. I mean, it's the same thing. We are saying minus A plus B is B minus A, right?
Ah, okay, I see.
I'm only writing this as B minus A. I'm not doing any change, right? The only
Right.
thing is, you know, I normally would like, so the formulas are A plus B or A minus. You get the idea.
Hmm.
So it's better to keep them as such. Otherwise, you are putting minus minus in between, and you know that is where I've seen students making mistakes. So I'm just trying to avoid. Remember, the angle is 2 pi by 3. So when you do for tan 2 pi by 3, you are in quadrant 2, right? And
Right.
3 pi by 4, you're in quadrant 2, where tan is negative. So both the values will be negative. So you have to be careful when you expand and simplify. Okay?
Right.
Good. Tell me, next question, please. Question number 7?
Given sine, yeah,
Read,
given
read.
sine A equals 5 over 13 and sine B equals 4 over 5, both A and B are acute, find the following. I think I can do this when you're just expanding as per the A and B values.
Okay. So sine alpha and beta are given to you.
Right.
Beta is 4 over 5 and both alpha and beta are acute. That means you are in quadrant 1. That means both are positive. You're right. Just make a right triangle, right?
Right.
And once you make your right triangle, you then get the third side. You find the sine and cosine both values and then substitute. Correct. No problem. You can do it. Next question, please.
Develop form. Oh, I didn't get this one. Develop formulas for cot A plus B and cot A minus B. I know it's the inverse of tan.
Yes. So very easy. So cot of, let us say, let me write A plus B will be what? 1 over tan of A plus B, correct?
Right.
Which is same as tan A plus B, right in the denominator. Tan
Right.
A plus tan
Plus
B,
tan B over 1 minus tan A tan B.
done. And if we use positive instead of negative,
And it'd just be 1 plus and then
yeah,
tan A
if I
minus.
write negative here, this will be positive and this will be negative.
That'd be
Done.
negative. Right.
So we're done with that. Good
And
job.
then and then
Move
they're
on.
just saying you find the
Now apply
value.
the formula and get the
And
answer.
they've just given you A and B, so it's fine.
So Scott 75. You have to write 75. See, the question now is slightly tricky. Let's look into it. It is
Okay.
cot of 75 plus cot of 15 degrees, correct? Now,
Right.
75 and 15 can be written as what? Something plus and something minus. Can you do that?
Right.
What?
Something plus and something minus?
Yeah. What is the middle value? What is 75 plus 15 divided by 2?
Oh, that's just 90 divided by 2.
You get the idea? 45, right?
45,
So from
right.
45, you are subtracting 30 and adding 30. So that is how you figure out the middle value. So now we can write this as cot of 45 plus 30 in degrees plus cot of 45 minus 30 degrees. You see that is cos of 15. You get the idea.
Oh, okay.
And then you are going to solve this question. Is that clear to you?
I don't understand why we use 30.
Because how will you find the value of cot of 75?
Oh, I see.
So, you understand? So, you have to use 45 and 30 to find that value.
I just still don't get it as much.
Okay, how will you do the question? Tell me.
I just thought you substitute the values in for A and B as given.
Then, no, this is cot 75 plus cot 15.
Oh, okay, then I would have just expanded for cot 75, so I just did 45 plus 30.
Correct.
Oh, and then
Yeah,
you
now
have
you know the formula of cot A plus B and cot A minus B. You get the idea. Cot A plus B formula you just figured out is here tan A. Oh, sorry, I should write cot. So we are writing in terms of tan, right? 1 over 10. So tan A plus tan B, right?
right.
Over 1 minus tan A tan B. And then you know cot of A minus B is again we have tan A minus tan B over 1 plus tan A tan B, correct?
Right.
So individually, you can find these values and add them up. So
I
cot
see.
75 will be calculated with A plus B formula. Cot of this will be calculated from this formula. And then you can add them up and get the value.
Right, because cot of 15 is just going to be your 45 minus 15.
Yes.
Right? Okay. I see. That makes sense.
Yeah. So it is slightly lengthy. Okay. You have to do them individually and then add them up. Okay.
Okay.
Yeah. Because otherwise, if you mix them up, it will be more difficult for you. So go in steps.
Okay. And develop a formula for sine 2a. I think this is just our double angle.
Yeah, we know that. 2 sine A
Yeah.
cos B, right?
Yeah. So that's just 2 sine a cos b.
Yes.
And then you have to do sine
Without
120.
using tables, find the value of sine 20 and sine 45. You can do it, right?
Yeah. Sine 120 is just going to be your 2 times 60, and then sine 45 is just going to
Straight
be,
away, you know.
yeah. It's just, you have to, because these are your values of your
You
A.
can use the special triangle, right? You know, sine 120 means you are in this quadrant, acute angle is 60. You get the idea, right? So it is
Mm-hmm.
sine 60 plus sine 45, correct?
Oh, okay.
So go with that.
Okay. And then find sine 2a of sine A equals 8 over 17.
Correct. So you know the formula, you can use it. So when you have sine A, I'll write down. Sine alpha is given to you as equal to 8 over 17, right?
Right.
So basically, you can think about your triangle whose sides are 8 opposite side. This is the angle alpha and 17 this side, correct? So what is
Right.
this side equals to? 17 square minus 8 square. How much do you get?
Oh, then you just use your Pythagorean theorem.
Yes. And now, yes, use. And then you know sine
It's 15.
2 alpha equals to 15, right?
Right.
Sine 2 alpha is 2, sine alpha cos alpha. And cos alpha is 15 over 17, right? So it is 2 times sine alpha is given to you 8 over 17
Mm-hmm.
and cos alpha is 15 over 17. So that is your answer.
Oh,
2
and then you
times
find
8 over
the,
17 and 15 over 17. You get the
and then,
idea?
so is 15 over 17 your value? And then do you have to solve further, or do you just say, oh, sine,
Calculate.
calculate?
Yeah.
Okay.
17 square will be in the denominator, 2 times 8 times 15 will be in the numerator.
Right. And then you calculate the answer from here. So
Correct.
15
That's your answer.
over 17 times 8 over 17 times 2, which is
Correct.
3. Okay, I see. That's the end of this, and then I can bring up the next one, or if you have any questions, then I can do them.
You bring next one. Let's complete all your worksheets.
Okay, I just need to stop sharing for 1 second.
Yeah. So did you understand all these concepts which we went through?
Yes, for the most part.
Perfect. No problem. Continue.
Okay.
Correlated angle identities. Okay.
I think we
Read.
just, I think we just did some of these though.
Yeah. So you can ask whichever question you want to, right? So we'll do whatever question you will be asking.
We can do 1C because it has a
What?
reciprocal. Yeah,
Okay.
the cot.
Can you read the question?
Um, cot. Oh, use correlated angle identities to simplify, then evaluate, give exact values. So
First.
cot pi over 2 plus pi over 6.
So whenever you think pi over 2 plus pi over 6, in which quadrant will you land?
Pi over, it'll be your second quadrant.
And when you apply the cast rule, what do you get?
It would be a negative tan value.
So it will be negative. Do you understand first thing, correct? Because you are in quadrant 2 and negative tan value of pi by 6. Does it make sense to you? How easy it is?
Yeah.
That is it. And you know that pi by 6, just make those triangles. So never miss that part. As soon as you start your work, just put this triangle here. Pi by 3, 1, 2, square root 3, correct? This is pi by 6. And now you know the answer. You have tan of minus pi by 6. Look from here, 1 over square root 3. Now, most of the time, we'll write this as square root 3 over 3. Rationalize it. Is it okay?
Right.
Negative answer, of course. Correct. So, that is how you're going to do it. Clear?
And then you just do the next one and you just add it up, or then you find,
That
oh
is your
no,
answer.
oh, you just find your, then you just expand it using the formula, and then you
No,
calculate
no.
from there.
This is direct. No formula expansion. We wrote cot pi by 2 plus pi by 6 as minus 10 pi by 6.
But then they said, then evaluate, like give a value,
Yeah.
right?
So the value is square root 3 over 3 with negative sign.
Wait,
That-
I'm confused because if it's cot pi by 2 plus pi by 6, what I would have done is I would have gone into the tan formula.
No formula required. Cot, it is a cofunction identity. cot becomes tan becomes cot. When you do pi by 2 plus or minus theta, correct? So let me rewrite. So we have cot of
It said
pi by
correlated.
2
It's a
plus,
correlated angle identity. So I thought that's why you had. Oh, it's not your compound angle one. It's just your
not it. So
cofunction.
this is equals to minus tan of pi by 6, which is equal to minus pi by 6 is 1 over square root 3.
What happened to the
Which
pi
is,
by 2, though?
no, that is the cofunction identity, right? So when you do pi by 2 plus theta, then it becomes tan. So
Oh,
do you get the idea? Let me go back to cofunction identity so that's absolutely clear to you. Let us say this angle is theta, right? And this is 90, correct? So this angle is how much? This is pi by 2 minus theta. Is that okay?
right.
Now, what is cos of pi by 2 minus theta equals to? When you're looking from this side, it is that becomes the adjacent, right?
Mhm.
And this is the hypotenuse. But if you look from sine, that is the opposite side. I mean theta. So this is equal to sine of theta. Do you get the idea? So cos becomes sine.
Oh,
Sine becomes cos. Tan becomes cotangent. Cotangent becomes tangent. That is what we did. Moving from.
oh, I see. I
So if
see.
so, don't apply that, right? So use this identity. Okay. This is called actually co-function identity.
Okay.
Well, the question says apply, use correlated angle identity and simplify. If you use correlated angle identity, uh, because correlated means what for you? Related and correlated. Correlated is the same as cofunction, right?
Yeah.
Or is it related angle
I think it's the same thing
as
as
cofunction?
cofunction.
What
I
I'm
think
saying is cofunction angle. Yeah,
I think so. It's the same thing.
you can check the formula. Is it
Yeah.
correlated or cofunction?
Yeah, it's equivalent trig function, so
Yeah,
the cofunction.
correct. So that's clear, right? So only these three simple steps, you get your answer, correct?
Right. So you just have to take your tan of the value that you are adding or subtracting, not the theta.
No, because that is
That is
cofunction.
standard. That's just standard.
So that is
Um,
correlated angle. Correlated cos and sine are correlated. Tan and cotangent are correlated. Okay?
okay.
Right.
So can we do one of the sine ones then?
Sure, sure. Say which one? Sine. I'll just write sine of
Sine
what?
sine 3 pi over 2 minus pi over 3.
Let me sine 3 pi by 2 minus pi by 3.
Pi by 3.
So first thing you have to see in which quadrant you are. Right? Simple methods I have. 3 pi by 2 minus something means you are here, right?
Right.
In this quadrant, sine is negative, correct? So it becomes what? We are looking for a negative value. So negative sine becomes cosine. Cos of pi by 3. Done. Done.
I see.
You get the idea.
Yeah, so sine becomes cosine, and then your
Quadrant 3, sine is negative. So put negative of the acute angle pi by 3.
so for these cofunction identities, your sine becomes your cosine, your tan becomes your cotangent, your cosecant becomes still your sine, right?
Yes.
And then your secant is still becoming your cosine. Those stay the
Correct.
same.
Correct.
Okay. Can we try number 2?
Sure.
Mm,
Tell me, we are looking into secant 4 pi by 3. Correct?
right.
So, and we are wanted to have correlated acute angle. So 4 pi by 3 happens to be here.
Here, yeah, in the third quadrant. And then you have your related acute as pi by 3.
So this is 4 pi by 3. Correct?
Correct.
Now 4 pi by 3 is as good as 8 pi by 6. Do you understand? 4 pi by 3 is same as 8 pi by 6, correct? Why did I write like this? Mainly because when I know it is 8 pi by 6, then I know this angle is pi by 6. Do you see that?
Right.
Now I can write this as related acute angle in terms of pi by 6. So secant being in the third quadrant becomes negative and secant becomes cosecant of pi by 6.
Right.
So you have to do like this to get the right answer. I mean, the right way of doing it. Is that okay? Does it make sense?
Yes.
Slightly complicated. So I wrote 4 pi by 3 because it's an odd number. So 1/4, when I divide the odd number, I'm not getting the full thing. You get the idea.
Right.
So I made it a double so that in smaller angles, I get a full number pi by 6 as my co-reference angle. So that is how you're going to do it. Very important question. Do you understand what I did? So first thing, I wrote secant 4 pi by 3 as equal to secant 8 pi by 6. You get the idea?
Doubled it. Yes, I see
And
that.
then I wrote this as secant 9 pi by 6 minus pi by 6. Do you see that?
Where did you get? Oh, 9 pi by 6? How?
9 pi by 270.
Oh, I
3 pi
see.
by 2. You get the idea, doubled it, right?
I don't get why we couldn't have just left it as uh our 2 pi by 3.
No, 2 pi by 3 is not acute angle, and that was the wrong drawing.
Oh, I see.
You get the angle? 2 pi by 3 is a big angle. 2 pi by 3 is 120 degrees. How can
Oh,
I make it in that less than 90? No,
right.
that was wrong.
If it's 120, then it can't be greater than
That
180.
can't be there, right?
Yeah.
That is the right solution, right? You get the idea. Definitely now you can evaluate because you know special triangle, pi by 6 angle.
Right.
Can you tell me the answer, please?
Your pi by 6 would be pi by 6 at top 1, 2, root 3. So this is just cosecant, so it is your adjacent over
Opposite over this, so -2 is your answer.
opposite. Oh, cosecant is sine.
In
Yes.
reciprocal. So -2 is your answer. You get the idea.
Right. Yes.
Very
And so
important question. Make it a note. This might just come in your test.
right.
Right. Next question, please.
Um, I think can do. We can do this
Yeah,
one
sure. Sure.
3C.
Sure, sure, sure. Can you
Or
read what that question is?
Um, sine pi plus x
Wait.
plus
Sine
cosine.
pi by x can be written as minus sine x, right?
Right.
Next term plus
Plus cos pi over 2 minus x.
means min plus cos means plus sine x. Is it okay? So I'm writing them as correlated. Cos of pi by 2 minus x is sine x, right?
Yeah.
Next term,
Plus tan pi by 2 plus x.
cofunction identity minus cot x. Is it okay? Next
Right.
term, oh, that is all.
Plus
Tan
plus
3 pi by
tan
2 minus x. You
2
are in
minus
quadrant 3, so
yeah,
cot x.
cot x. Yeah.
Now you can simplify, it is equal to 0. Do you see that? Minus sin x plus sin x minus cot x plus cot x, 0.
Right. I see.
So
See.
just convert as you read into their co-function, correlated, you may say, or related identities. So remember one thing, that is, let me again sketch this. When our when we say related identity, so you're using two terms. Related means you're looking with horizontal axis. Do you understand?
Right.
Correlated means You are looking from vertical. Do you understand? You're looking from here. Do you understand?
Yeah.
So correlated, you will change cos to sine, sine to cos, but you're looking from the vertical, pi by 2 plus minus or 3 pi by 2 plus minus, correct?
Right.
With related, you're looking from pi or 2 pi, correct? Remember that part.
Okay.
Great. Next question, please. Can you
Um.
do D? Wait. I like
Yeah.
you to do D, yes. Okay.
Okay.
Read and I'll do on the side. You read and then do it.
Okay. So D is sine pi over 2 plus x minus cosine 3 pi over 2 minus x plus sine 3 pi over 2 minus x. Oh, it's plus x minus cosine. I know it's sine x.
Okay. Sine x is correct.
What I did, I don't know if this is right, but I turned sine pi over 2 plus x into cosine minus x.
Minus cos x.
Oh.
No.
So
Pi by 2 plus x is plus, right? So plus cos x, right? Second term,
and then I did minus cos 3 pi over 2 minus x is to sine x.
because
But
then minus and minus becomes plus, right?
minus becomes plus. And then I did sine 3 pi over 2 minus x. I turned it into minus cos x.
Correct.
And so that gave me the answer of sine x.
Correct. That is correct. Good job. Likewise, you can do the third one also, no problems, right? Next question, please.
My question is, when you're doing the cofunction identities, and for example, here sine pi over 2 plus x, we know that when we do the cofunction identity that your cos would have to be negative because pi by 2 is in the second quadrant.
So you have a positive answer, right?
Yeah, so if you have a
And sine,
positive answer, do you apply the negative to the x? Is that why it's
no.
positive cos x?
You have sine pi by 2 plus x. You are in quadrant 2. That means the result is positive, correct? So we write positive.
So the
And
way that
sine changes to x. Yeah.
I see. So the way that you do like the cast rule is after you find the result.
Yeah. You can do, yeah, either.
No, because that makes a lot more sense. Because I was trying to figure out like where to put my negative.
Yeah, don't put ever inside, outside only, whatever you.
Okay, so that equals sine x. Yes, I understand. Okay. Let's do one of these. Okay.
In the last question, go back to your previous page, please.
Yes.
Yeah, last question. Question number 6.
Right.
Can you try that?
Sure.
Yes.
The first one.
Yeah, A.
Cosine pi minus pi
Pi
plus
plus x. Pi plus x, right?
x cosine pi over 2 plus x. I believe it's
So
plus x.
cosine pi plus x will be minus cosine x, right?
Cosine pi minus x. So this equals to
Sine.
sine cosine is pi. It'll be negative. So it'll be sine x times again sine x over cos pi minus x would be sine x again. So it'd just be 1, right?
No, there are 3 terms. So sine and sine will cancel, so you'll get cos x, minus cos x. In the
Why
first,
did you? Oh, how did you get a negative values for all of them?
oh, okay, let's go through it once again. Then.
Oh, because it's the cast rule. I forgot to apply my negative.
So first term is cos pi plus x.
Right.
So basically, pi plus x means you are in quadrant 3, right?
Right.
And therefore, you are negative. So negative cos x. Is that clear to you?
Right. Oh, so that, okay, so you have to apply it in that sense and then switch it to.
Then we have cos of pi by 2 plus x. So when you say pi by 2 plus x, in
You're in
that
the
case,
second
you are
quadrant.
in second quadrant. Again, negative. But this is a correlated angle. So negative sine x. Is that clear to you?
Right.
Then you have a component which is cos of pi minus x. Cos of pi minus x. Now in this case, you are here, right?
Right.
Again negative, right? So it is equals to negative of cos x because it is a related angle. So whenever related angle, cos remains cos, sine remains sine. But when it is correlated, sine becomes cos. Think like this. Is it okay?
So the related means that the cos remains the cos, but how do you know if it's related or not? Is that based on like the x and y values?
Horizontal axis means related.
Right.
But if it is a vertical axis, let me just highlight in different color.
Oh,
Pi by 2 plus x, correlated. This one pi, horizontal axis related. You get the idea.
I
If you
see.
are doing pi or 2 pi, it is related. If you are
Right.
doing pi by 2 or 3 pi by 2, correlated. That's the whole idea.
Okay, I understand now. I
Good.
think I can do this whole sheet again by
You
myself.
should. And very easily it should flow through, right? No
Right.
problem. Should just flow through. So we'll clear this and move on to the next. Good job.
Okay. Um,
Ask the question.
I want to find one that is worthy of asking.
No, ask any question. Don't worry.
Um, okay, let's do this one.
Okay. Question number
This number 9.
9. Okay, 9 is here, right? Can you please read the question?
Jim needs to find the sine of pi over 8. If he
Mhm.
knows that cos is pi over 4 equals 1 over root 2, how can he use this fact to find sine of pi over 8? What is his answer?
So pi over 8 is half of this angle, correct?
Right,
So you know the double angle formula. You can use that. You remember?
right,
So cos, let's write down. Cos 2 theta, we wrote in three different ways. One of them was in terms of sine, 1 minus 2 sine squared
9
theta.
over 8.
So 2 sine squared theta. 2 sine squared theta is basically equals to 1 minus cos 2 theta, correct?
Yeah,
Now, so sine theta basically is what? So you square root and divide by 2, right? Basically, we derived this formula yesterday, last
right,
class. And there'll be plus minus. We choose the sign plus minus depending on the angle. Pi by 8 means related acute angle, correct? So it is
right.
positive. So we have a positive answer here. Now, if theta is pi by 8, if theta is pi by 8, then what is 2 theta equals to? Pi by 4, right?
Yeah,
So you know what cos pi by 4 is. So you can write sine of pi by 8 equals to square root, positive of course, 1 minus cos of pi by 4 over 2, correct? So which
right.
is square root of 1 minus 1 over square root 2 divided by 2. Do you get the idea? Now you simplify and get your answer, right?
Oh, so we're using our math angle here.
So I'll prefer to write 1 over square root 2 as square root 2 over 2 so that the denominator 2 will come outside. So let me
Right,
show you this work. So we have square root of 1 minus. I'll prefer to write this as square root 2 over 2. You get the idea? Over
yeah,
2. So that you know that 2 and 2 is 4, right? So it is now 2 minus square root of 2 over 4, which is half of square root of 2 minus square root 2. That is your answer.
I see. Okay, that makes much more sense.
Correct.
Okay. Um, Okay, let's do this one right here. Number 11.
Question number 11. Okay. 11. Can you please read the question? Use double angle formula to develop a formula for sine 4x in terms of x, right? So that's not difficult. Sine 4x will be what? Sine 4x. We need to
Is
find,
2 sine A
yeah,
cos A.
equals to 2 times sine 2x cos 2x. Is that okay?
Yeah,
Double angle formula. Again apply 2 times sine 2x is what? 2 times sine x cos x, correct?
right,
And cos 2x is what? You have three different formulas. So let's write in terms of sine itself, right?
right.
So it doesn't matter. You could write in terms of cos also, but any you want, any you want. Okay.
Why are we doing why did we turn this 2 sine 2x cos 2x into 2 times 2 sine x
Well,
cos A?
read the question you want in terms of x, right? So we have to break them. I don't have space here to write, so I'm writing in two lines, right? So what is
Right,
cos 2x equals to? You can use either one cos square x minus sine square x, or you could write any one of them. Doesn't really matter, right?
right.
So let's write down in
Oh,
terms of
because sine 2x is 2 times sine x cos x.
yes, yes.
Okay, I see. And
So
then we're trying to find the cos of 2x, so then we have to use we can do it in terms of our sine or cosine.
let me use 1 minus 2 sine square. Since we are talking about sine 4x, correct? So
Right,
we'll give preference to this. And now you can expand and write down the answer. So it is 4 sine x cos x, right?
right,
Times, this is when you multiply by 1, right?
right,
Minus, when you multiply the other factor, you, you get 8 sine cube x cos x. Does it make sense to you?
right. Because you just
Distributive
expanded,
property. Yeah, just
yeah, you just distributed it. Okay, that makes sense.
yeah.
What about this part? Use the formula you developed in part A to verify sine 2 pi over 3 equals sine 8 pi over 3.
Yeah. So basically, if you see, 8 pi over 3 is 4 times, right?
Right,
So sine 8 pi over 3 will be equals to sine 4 times 2 pi over 3, right?
right.
So to calculate the value, what will you do? You will plug in the value of 2 pi by 3. You can use the formula and find all the answers, right? So instead of x, write 2 pi by 3 in all that formula, right? 4 times. Because you got sine 4x, right?
Oh, so you can just do the double angle theorem twice and then you can get your exact value.
Yeah, but they are saying use the formula you develop. So you have to
Oh, so this is the one 4 sine x cos
4
x.
times, yeah, you have to write sine of 2 pi by 3, correct?
Right.
Cos of 2 pi by 3
And then you do minus 8
minus
sine
8 times sine cube,
2 pi by 3. And then you go cos 2 pi by 3.
calculate your answer.
Right.
Yeah, like this is what they expect from you. Okay?
I see. I understand. Okay, that makes much more sense.
Perfect.
Do we have time for another question? I think we
Yes,
do.
sure. Let that be the last question.
Right. Okay. Um, let us do um an easy one. Okay. Here we
Any?
go. Prove the following trig identities.
Okay,
Cos x squared x plus sec squared x equals cos x squared x sec squared x.
correct. So when you do these identities, you should know your Pythagorean identities. It's a good
Right.
idea, right? So let me write down all of them here. It's secant, let me rewrite. I'll write all three of them. Is it okay?
Right.
So sine square theta plus cos square theta equals to 1. 1 plus tan square theta,
Equals to sec squared theta.
sec square theta. 1 plus cot
Squared
square theta,
theta equals cosecant
cosecant
squared
square
theta.
theta. So you know your identities, right? Now the question here is cosecant square cosecant square x plus secant square x, right?
Right.
Now you got this. Now, if you look into the identities themselves, and you want to prove this to be product of secant x and cosecant square x, right? You want them to be as a product of that, correct? So sometimes what I prefer is write these identities in sine and cosine.
Okay.
You get the idea.
Right.
You could get direct also. So cosecant is 1 over sine square x
Right.
plus 1 over cos square x, correct?
Correct.
So when you cross multiply, you get cos square x plus sine square x, and the denominator is sine square product of sine and cosine, correct? Common denominator. The
Right.
numerator is 1. So 1 over sine square x times cos square x, which is same as cosecant square x times secant square. Do you see that? Because in the numerator, you have cos square x plus sine square x, which is 1. And so 1 divided by the product of sine square and cosine square is what is on the right hand side. So we say this is equal to right hand side. And that is how we started from left hand side and showed this is equal to the right hand side. And therefore, we have proven the identity. Is that correct? We get it?
Right, because you want to make both of the denominators the same, so you treat it kind of like a rational function to an extent.
Yes, yes. And we proved the identity. So
I
many times in identities, converting them into sine and cosine could be a good strategy. Okay,
Right.
so we adopted that this time.
Right. Like for here, we can for secant squared secant x minus secant squared y, tan squared x minus tan squared y. We can just use 1 plus tan squared
Yeah,
theorem.
yeah. So
So
second one, it is better to write 1 plus tan square theta. Then
right.
those 1 cancel and you get tan square in one shot. So you do not have to convert to sine and cosine always. You could use these identities directly, correct?
Right.
So you have to make a judgment. When you see the question, it will automatically come to your mind, apply that strategy. Okay?
Right.
Great. So have you understood all this?
Yes, I just have to practice it a little bit
You
more.
have to. So we'll end the class. I'd like you to summarize today's learning. So what did you learn today?
We learned how to use trig identities. Then we also learned how to do our cofunction identities. So basically, we learned if it's on the x-axis, then that means that they're just related. But
Correct.
they're on the y-axis, like y to y, that means that they're correlated. And
Correct.
from there, you can do sine equals cos, cos equals sine, or um, cos equals to secant, etc., etc. And then you can use your related acute to solve and evaluate, for example, sine 11 pi over 12.
Correct.
And by using your related acute, you can then use your compound theorems and then
Correct.
solve from there for the exact value.
Perfect.
And we went over the cast rule again.
Yes, yes. That's good. So very good. I hope all the things are absolutely clear. But once you do the questions yourself, they will streamline and you'll have the confidence. Okay,
Okay.
then. All the
Thank you.
best. Thank you. Bye.
Bye.
Good night.